Okay, so we have the following problem. We have a set of horizontal and vertical line segments, and we want to store them in a data structure. So given a rectangle, we can find all the line segments that intersect the boundary of this rectangle. Without loss of generality, we could just focus on the input set of line segments that are horizontal when the query is vertical. Okay, so because we could decompose this query rectangle into 2 horizontal line segments and 2 vertical ones. So it's sufficient just to solve this case. Before solving this general case, let's look at an easier case when this vertical line segment is actually a line. So it goes to infinity from top and the bottom. So obviously solving this problem should be easier than solving the general case. So as a warm-up, we'll try to solve this case. That brings us to the concept of interval tree. So to solve this problem, we're going to use this interval tree structure. The interval tree is relatively easy to describe, and it basically works like this. We want to build a balanced binary search on the endpoints, but unlike a normal binary search, we might store a lot of information at every internal node. To be more specific, we find the median endpoint. We find the endpoint that is in the middle, or that is median x coordinate, that is in the middle of everything. So remember that this is done with respect to the endpoints, right? In other words, if I have n intervals, that gives me 2 times n endpoints. That gives me 2 times n x coordinate. And then I find the median, the endpoint, which has the median x coordinate among all these endpoints. Let's say it's this one. Then I draw a vertical line at that x point, and I look at all the line segments that intersect this vertical line. So these are all the green line segments that intersect this vertical line. I store all of these green line segments at this node. So this node potentially has a huge list of line segments that are stored here. The remaining line segment in the input either completely lie to the left of this vertical dividing line or completely to the right. So then I do a recursion. So this recursion is on the set of line segments that are complete to the left and complete to the right, and that's essentially how I built the interval tree. Since this division line is the median x coordinate, the size of left and the right subproblem is at most half of the n. So the size of the left and the size of the left is at most n over 2. So this means that the recursion depth is log n. In other words, the depth of an interval tree is at most log n. But of course, it is possible that this interval tree has constant depth. So for example, if your input is something like this, right, then this could be the median x coordinate, and once you draw this line, then all of these line segments could be stored at the node. So if your picture looks something like this, then your interval tree has only one node that stores all the line segments. So this is a little bit different from what we're used to. So just have this in mind.